Heyo! So, looks like I'm sick. So, today I'm giving you a recording of the rest of the lesson so that way you can finish the rest of the homework no problems. Remember, it's 4-3, 11 through 19, due the Monday we get back. Make sure you do it. Okay? You have about enough time to do one problem a day. You can definitely get this done. Okay? Most of them are odd. 5 out of 4 are odd. Okay? And that's not to say use the back of the book to cheat, but rather make sure that you try and fill them out to the best of your ability and then double check. Alright? Now, when we last left off, we were looking at these two congruent triangles. Okay? And with them, we figured out that AB is congruent to DE, and that's because they are corresponding sides of these congruent triangles. Because of that, they are congruent, and that's our justification right there, right here. Corresponding sides of congruent triangles are congruent. Okay? From there, the rest of this is pretty simple. We use the definition of congruent parts, or congruent sides, angles, not congruent angles, definition of congruent segments. To justify that they're equal, then we substitute their values, and then we add 2 to both sides of the equation using the addition property of equality, and then we divide both sides by 2 using the division property of equality. Alright, so if you didn't get that copied down, get that copied down now. The sub will pause the video for you. Otherwise, let's keep moving forward. Now, using the same triangles, same scheme, let's try and find the measure of angle F. Now, the measure of angle F in this one is located right here. Now, in order to figure out this angle, we need to know both this angle and this angle. Now, we know angle D. It's a right angle, it's 90 degrees. But what about angle E? Well, let's start up with the setup that we do know that all 3 of these angles will add to 180. Okay, so if they add to 180, that's our triangle sum theorem. From here, though, we need to figure out, well, how can we figure out the measure of, let's see, how do they label it here? DEF. How do we find this measure? Well, let's look at our congruent triangles. So which angle corresponds with E, with DEF? Hopefully you guys figured out that it's ABC, right? If we look at our letters, angle B and angle E will definitely correspond. So we find that we find out that ABE or ABC is congruent to DEF. And that is corresponding angles of congruent triangles are congruent. Okay, so this time we're naming our corresponding angles. That's the difference. Now, again, we can use the definition of congruent parts, of congruent angles, to set them equal to each other. The measure of angle ABC is equal to the measure of DEF. And we also know what the measure of angle ABC is. It's 53. So by using the transitive property of equality, we just replace, or we can say that the measure of DEF is equal to 53. Then we can use substitution, the substitution property of equality, to state that angle DEF is 53 degrees and measure of angle FDE is 90 degrees. So then we can simplify and subtract to both sides, and we find that the measure of angle F is 37 degrees. Okay, so the sub should give you some time to copy this down if you need it. At this point, we're going to move forward. So now we're looking at a different kind of example. So again, we have some congruent triangles. Make sure you know which sides correspond. So let's find the value of x. Okay, this one should not be too difficult. Okay, so our x is located right here, right in here. So what can we do? Well, since we have a right angle, come on mouse, where are you? Since we have a right angle right here, and we have this angle here, what happens is we can say that these are both right angles, that BCD and BCA are both right angles because of our definition of perpendicular lines. Because, well, we learned that in chapter 3, and so they cut right angles. Whenever you have right angles, you got perpendicular lines. It's pretty awesome. So using that, we can say that they are congruent by the right angles theorem because all right angles are congruent to each other. That's what the right angles theorem says. It's kind of a lame theorem, but it's helpful in this case because then we can set them equal to each other through the definition of congruent angles. And then since we know that BCD is 90 degrees, we can just substitute its value out, and we can substitute the measure of BCA for 2x minus 16. And then we add 16 to both sides, addition property of equality, and then divide by 2 to both sides to get 53. Okay, not too bad. The sub will pause it here if you need time to copy that down. So, using the same triangles that are congruent, now we're going to try and find DBC, measure of DBC. Now this is interesting. We're looking at DBC, that's this angle right here. So we're going to take a different approach. Okay, on this one, oh come on mouse. On this one, the corresponding angle to DBC is what? ABC. So we can find ABC pretty simply because we already know that this angle right here is a right angle. We just proved that in the last proof. And then right here, we know that this is 49.3. So we can easily figure out this angle and then say, well, since these two are congruent, now we know angle DBC. So let's look at a proof for that. So first, we have our triangle sum theorem, again saying that all internal angles in a triangle add up to 180 degrees. Okay, so we have our ABC, our BCA, and our angle A. All the measures of those add up to 180. Now we can replace their values. We know that BCA is 90 degrees. We know that measure of angle A is 49.3, so we can substitute them in. We can simplify, and we can subtract. Subtraction property of equality. When you do so, you'll find that the measure of angle ABC is 40.7. Sweet. So then guess what we can say now? Angle ABC is congruent to angle DBC because the corresponding angles of congruent triangles are congruent. So then we use our definition of congruent angles to say that their measures are equal, and since we know what the measure of angle ABC is now, we've replaced with substitution or transitive property of equality, whichever one floats your boat. Since it's equality, you can use substitution. And there you have it. Okay, the sub will pause if you need to copy, but for now I'm going to keep moving on. Example 3. So this one's quite fun. Now we're trying to prove congruent triangles. Okay, so that's the difference here. We're trying to prove congruent triangles. So that means we have to prove that all the sides, all corresponding sides match up here. So we're saying we need to prove that AB is congruent to DE. We need to prove that BC is congruent to EC. We also need to prove that AC is congruent to DC, and all the angles and all that jazz. So that's a lot of fun. So let's take it bit by bit. I want to show you this one. We'll walk through this one and I'll show them to you. So maybe you want to copy down this picture, okay, and copy down this information. The sub will pause it so that way you can do that. Now if we're looking at this thing, okay, we definitely should always start with our given. that we have angle A is congruent to angle D. That's a good place to start. One of our angles is congruent. Okay? Next, we also know that AB is congruent to DE. Lastly, we're given that AD bisects BE and BE bisects AD. Okay? So first, let's start with the angles because the angles are easier. So we have angle A is congruent to angle D. And then looking at that picture, I think we have some vertical angles. So we can say vertical angles theorem, vertical angles are congruent, whatever. But we find out that angle BCA is congruent to DCE. All right, 2 out of 3 angles proven. 2 out of 3? 3. That number reminds me of the, oh yeah, the third angles theorem, right? If we have 2 angles in 2 triangles congruent to each other, next thing you know, that means their third angles must also be congruent. So great, we have all of our angles proven. What's next? Our sides. Now the sides are a little bit different. We have to recall what this means. If we have these bisecting each other, that means they're both cutting each other at the midpoints. Therefore, they cut them into congruent segments. So we find out that through the definition of bisectors that BC is congruent to EC and AC is congruent to DC. Now, I don't know about you, but I think we've proven now all 3 sides are congruent, 1, 2, and 3. Oh, nice, and all 3 angles. Sweet. So then right there, when all that's proven, you can say these 2 triangles are congruent to each other, and that is the definition of congruent triangles, because all sides and all corresponding sides and corresponding angles are congruent to each other. So I'll let the sub pause and let you finish that up. I'm going to keep moving forward. Here we have something about some kind of engineering application, but really it's just another proof because we're trying to prove that QPS is congruent to TRS. Okay, so if we're looking for QPS and TRS to be congruent, that means Q and T need to correspond here. R and P and both sides of the S need to correspond. Okay? So those are the angles that we're trying to prove are congruent and things like that. So far we know that PR and QT bisect each other. So since we have since we know our definition of segment bisectors, we definitely know that these 2 sides are going to be congruent and these 2 sides are going to be congruent. So that's good. We also know that QP is congruent to RT. Okay, so that's going to help us prove all 3 sides are congruent. And then we have these angles. PQS is congruent to RTS. And that's good because these are corresponding angles and we're proving they're congruent to each other. So this is pretty much a repeat of the previous proof. Okay, so let's look through them. Again, we have our 3 givens. Okay, we have all that laid out. So what's next? Well, we can use our definition of bisectors, as I had said, to show that QS is congruent to TS and PS is congruent to RS. So there's all 3 sides proving congruent. Okay? Following that, I see a pair of vertical angles. So let's name them. That's angle QSP is congruent to TSR. Now, since it's both sides of angle S, you definitely, for these types of angles, since there's so many letters everywhere, you have to use 3 letters to name them. So it's very important to make sure that when you are naming them, that you are following their order of what is corresponding, which letters correspond where, and how that all fits together. Okay, that order really matters. Afterwards, since we have 2 angles of each of the triangles proven congruent, we can use our third angles theorem to justify their third angles being congruent to each other. And because now all of our corresponding angles are congruent to each other, and all of our corresponding sides are congruent to each other, we can say that these 2 triangles are congruent to each other by the definition of congruent triangles. And that about wraps this lesson up. I hope you all have a great Thanksgiving.